Oh, there you go.
Well, welcome to the September 21st, 2021 session of Tangerine and Hamside Technical Session. My name is Dave, KV0S, and many of us were involved in a week-long meeting this weekend, so we're kind of recovering from all the talks and interesting things going on. I had a role in streaming the video, so that was most of what I did last week. So next on the list is Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. It's been a good week, and I helped participate in Tapper. I presented 3 talks and helped co-author many others. So I think it was a good week, and should be another busy week here. I'm giving at least 2 club talks this week, and we have our new university president inauguration this Friday. So it's going to be quite busy.
Yeah, that's quite a bit. So next on the list, we have Dan in for XWE. Go ahead, Dan.
Oh, thank you, Dave. And well, other than watching DCC this weekend, I haven't really done a lot. Worked a little bit on scripts and been kind of putzing around a lot with Python lately. And that's about it. So back to you, Dave.
Well, very good. Next on the list is Dave Witten, WD0EAG. Go ahead, Dave.
Hello, all. I participated and more importantly, observed most of the weekend's meeting, DCC conference, and I've worked a bit on a testing software for Scotty and who knows what else. So I'm here. That's it for me.
Well, fine business. And next on the list is Dev KC3 PVE, sorry.
That's okay. Hello.
Yes.
Very good evening to everyone. So as Nathaniel said, we had a good start of our week here in Scranton. My laptop was not working well this morning, and I was thinking that it went very bad, but I went to see Nathaniel and he made some changes here, and I think it got the magic touch and it is working without much repair that we thought it would require. So
very good.
So that's the positive spirit that we're starting the week on.
Well, next on the list, we have Jim K4 BSE. Go ahead, Jim.
Good evening, all. I am embarrassed to say that I didn't get anything done on this project again this week. I've been working on a non-ham related project around here, and the guy who's helping me with it showed up unexpectedly last Thursday and stayed through Saturday, so I didn't get a chance to do anything else except work with him. And I've still got to go back and get the watch the videos from the DCC. So unfortunately, I don't have anything much to report back to Net.
Well, they are there in the full stream version right now, and eventually they'll get broken into individual talks.
That would be nice.
Next on the list is Bill, AB4EJ. Go ahead, Bill.
Thanks, Dave. Good evening to the net. Been working quite a bit on getting the software necessary to prepare the PSK reported data for the analysis that we're going to do on for the new NASA project, and putting some new wrinkles into that. Prepared for and participated in the DCC, and also discovered that my magnetometer 1 is seems to be a no code. I got it out of the pipe and doesn't seem to have been immersed in water or anything, but it is dead. So not quite sure what happened there. You see, it has the nice 3D printed spacers that I printed out to mount it in the pipe using the great STL files that Dave sent me. But who knows? So that's the news from Northport. Back to Ned.
Well, sorry for that happening, but thanks for being there. Next on the list is Bill N8ET. Go ahead, Bill.
Can you hear me all right?
Yes.
Okay, because it seems like every time I come on here, the audio has changed a little bit and it never works right, but I got it this time. So I haven't got too much done this week. I did talk to some people that came up to our Findlay Hamfest a week ago. And I mentioned that there was a fellow at the University of Alabama, and I think that's Bill AB4EJ. Is that right?
Right.
So they're both associated with the radio club down there, and I think I sicked him on you to give you some help if you wanted, and if you didn't, I'm sorry.
No, it's fine. It's fine. I have made contact with the radio club. Gave them a big presentation about the personal space for the station project, and what was heard in the room after that was just the sound of crickets chirping. So we'll see if there's anything more besides that. I'll be happy to work with them if they had any interest in it. So
these are two people. They're some people that came from Findlay and went down. They wound up moving down there several years ago, and they helped with the radio club. I guess they're advisors to it now. So they've gotten in, and they're looking for something for the kids to do. So I told them, well, there's this big ham side project, and so they sounded like that'd be pretty interesting. And so hopefully they'll get a hold of you. But I couldn't remember your call sign or anything, and they seemed to think they knew who you were, but they weren't sure. So they should be getting in touch with you. So anyway,
you see my call sign there. Just please pass it along so they can reach it.
Yeah, I'll pass it along to them now. So very good. Back to you, Dave.
Okay. Next on the list, we have B. Meyer. And unless you're somebody that I don't recognize, welcome. Go ahead.
Well, hi. I'm actually just sort of sitting in to see what this meeting was about. I'm interested in the personal space station, and just wanted to listen and see what these meetings were about.
Well, you're welcome. And please, if you find it interesting, we meet here every Monday night to work on technical issues of building the personal space. We're still in the development phase. And if you find something you're interested in, jump in and we'd be happy to have any help.
All right, I might do that.
Okay. Next on the list is, we called on Dave, so it's the other David, N1HAC. Go ahead, David.
Good evening, everyone. I was able to get on DCC Friday, get all of that, but Saturday had another event, so I'm going to have to go back and catch the things on stream or whatever. But seemed to be a very good conference. Little bit of Zoom idiosyncrasies, as is, I guess, we've come to expect, but not too bad. And the other thing I will mention is that I'm working on getting the Max 10 development board up and running, getting all its software installed. Looking forward to playing with that. So, and seeing what we can do for development. Back to Net.
Okay, and now another David Waugh, KE8QEP. Go ahead, David.
Well, hello, everyone. I enjoyed the DCC talks. I didn't have as much time to see them on Saturday, so I'll have to look at the recordings for those. Also, I think that all you young folks out there should realize that when you get to be my age, and I think I've really reached this point now, you get to a point where you really need your reading glasses to read the back of a transformer or to see what the table says. So you young folks out there, I'm just warning you. Back to Net.
Well, fine business. Actually, I have to take my glasses off to read them. And so next on the list is Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Congratulations to the DCC participants and presenters. Went pretty well. And I think we'll probably pick up quite a few more HAMSci interested individuals as a result. Back to net.
Next on the list is Hyomin Kim, KD2 MCR. Go ahead, Hyomin.
Good evening, everyone. Yep, same here. I've been participating in the TAPR DCC conference where I actually presented the science result as well. Yep, not so much done this week, other than I've been communicating mostly with Jules, who is interested in performing some kind of performance test for our magnetometer system, so which I really enjoy. So one thing that we've been discussing is what type of specification we want to show. So some parameters that we like to present at some point is the actual noise level of the magnetic sensor in a quiet environment, which can be done in the electromagnetically quiet shielding case. Resolution as well, field resolution at say maybe 1 Hertz. Directionality, that is angular resolution. So to what degree the sensor will respond to in terms of what something like that. And temperature and long-term stability. So that's something that we are trying to figure out at some point once we have more complete set of magnetometer sensor, and then we have more sophisticated test equipment. Otherwise, yep, that's all what I can say.
Well, fine business. I was just also wondering if you've dried out your house, the basement.
Oh, my basement?
Yeah.
Yeah, I mean, a lot of cleaning, no damage.
Well, that's good.
The interesting thing is that I only saw the aftermath, so I had a pleasant night. And then the next morning, we had a very beautiful morning. So I had no idea what happened in the basement. Oh. I can tell that some floor mat that I left on the floor moved, which indicated that there was a big amount of water. And I saw some fallen leaves here and there, which I never had. So, and all the boxes that I left because of this recent moving, all wet, including my old clothes. So, yeah, I mean, other than like a lot of cleanings, thankfully there was no real damage.
Okay, good. Okay, next on the list is James, KG4, DSG. Go ahead, James.
Evening, Dave and the group. Was attending the Saturday Zoom DCC. I'm still catching up on the Friday sessions, but I figured a lot of those were what this Monday call was about. So I figure it'll be another week or so before I get through that. Other than that, not too much going on here. Back to the group.
Okay. Next on the list is Jay, WB8 SBI. Go ahead, Jay.
Yeah, good evening, everybody. Likewise, I attended both days of DCC. My compliments to the TAPR crew for organizing and putting it on. Compliments to all of the speakers. Nathaniel, I found your talks really interesting there, and really appreciated them. Learned a lot also. Kilo Alpha 9 Quebec, his talks on the ARDC, the big endowment, that was also very interesting there. Nathaniel, I wanted to ask you a question. For my local club, the Hazel Park Amateur Radio Club and the General Motors Amateur Radio Club here in Metro Detroit, would you have any objection if I pulled some of the video from the DCC and presented it at club meetings? Or will the Tapper guys object?
It's fine with me.
I don't see any problem. We're all about disseminating knowledge.
Okay.
Yeah, as long as it's attributed, no problem.
Yeah. And just for general information, the General Motors Amateur Radio Club, its repeater is in downtown Detroit on top of the tallest building in the state of Michigan. It's like 72, 74 stories tall.
Oh.
So that they're the people that own that. Anyway, other than that, I really had a good time at DCC, and I'm looking forward not only to the opportunity, hopefully we can get to all do it in person next year, but also to the next Ham-Sci conference, and hopefully that will also be in person. Other than that, 73 to all, back to net.
Okay, thank you. Say, Dev, would you mute your mic?
Okay, sorry about that.
So next on the list after J, gotta figure this out. I guess it's Jim, 7J1AJH. Go ahead, Jim. Jim, are you there? Guess not. After that, it's Joe, W7LUX. Go ahead, Joe.
Spent the Friday and the entire weekend tracking 120 or so runners from Flagstaff up to the Grand Canyon, 100 miles. And we tracked them through every aid station and tried to account for ones that just disappeared. In other words, left the race and didn't bother telling anybody. So it was an awfully busy weekend and haven't gotten anything else done. Back to you, Dave.
Well, hopefully you enjoyed it. Next on the list is John in 8 OBJ. Go ahead, John. Sorry, Joe. No, it's John.
I could
Go
change
ahead.
it to Joe if you want.
No, it flips real quick. The list is always changing on me.
Yeah, let's see. I attended and presented at the Tapper DCC conference on Friday and listened on Saturday. Hopefully my choice for my presentation was appropriate. I haven't heard any feedback yet, so I don't know if I blew it on that or not. We had our first two Grape 1 failures due to lightning strikes in Fort Collins, Colorado, because they're flat. And my infamous little itsy bitsy TVS diode melted on both units. It was pretty easy to diagnose. You put an ohm meter across the input antenna jack, you should measure the 1 K ohm load, and it was measuring 0.0003 ohms. So once we unsoldered it, the station came back to life. So we might have to look into a larger, something that can take more energy, or to protect a little bit better and do something different. But that's for further down the list here. I also need, in retrospect to that, need to talk to Tom McDermott about his filter that he made for the Tangerine as an optional front end plugin, because I want to incorporate that permanently for the Grape 2 radio station. So I want to get a hold of Tom and get the schematic. Maybe if the schematic's up, I'll get it from that. But anyway, I want to get that schematic. I also finished the node conversion software. So if you were collecting node data without an assigned node and then got an assigned node and want to submit all the data, I've got that processing program now working, and I have to put that up on the web. I also put the distro on the Google Drive. I renamed it as .rev1.old because the next thing I'm working on is the WWV Amateur Radio Club has the web services FTP server up and running for us to use to upload everybody's node data every night automatically via Crontab's FTP job. So I'm in the process of getting that to work. And once I figure that out, I'm going to email everybody who has a node how to update it, but the new distro is going to have that built into it. So other than that, I haven't been up to much. Back to net.
Well, it sounds like you've been pretty busy. So next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I wanted to thank everyone behind the scenes and at Tapper DCC for a great conference and all the support that I received, all the emails that I received about my project. Thank you for the support and interest. With the roadmap of my project now, the plan is to get everything drawn up in an actual CAD program instead of in my notebook, and build up a bill of materials. And then hopefully after that's done, we could figure out how to get the layout funded, and we could go from there. One thing that I wanted to mention, I really enjoyed all the talks. John, I really enjoyed your talk about your great version 2 input amplifiers. Nathaniel, I really enjoyed your talks, and thank you for the support and the mentions. I also wanted to point out that it might be a good idea to give Phil Carnes' radio package a bit of a deeper look, because I really like the way that he designed his software. It's actually designed very closely to VLF-RX tools. It's very modular, easy to configure with command lines. With VLF-RX tools, data is normally exchanged between programs with named buffers, whereas Phil's is through IP multicast. That could be a bit of an issue if you have a LAN and your switch doesn't know how to handle IP multicast. It'll look like it's broadcasting to every connected port, but the way that everything is designed is really nice and efficient, and it might be a good idea to kind of look deeper into what he has. I'm going to be playing with it very shortly. It'll compile easily on OS X, and that's what I use too. So that's another reason why that I like it. Other than that, back to the net.
Well, fine business, Jonathan. And next on the list is John Ragland, KJ6IBP. Go ahead.
Well, I'm here to listen and learn and not yet really say anything.
Okay, well, you're welcome. And next on the list, we have Mike, AA8K. Go ahead, Mike.
Well, thank you, Dave, and greetings to everyone listening. John, sounds like that diode did its job. Jay, yeah, whenever I take off at the local airport, if it's a clear day, I can see the Rensen from over here in Port Huron. That's a pretty big building. And Scotty, congratulations. Lead well and prosper. Back to you, Dave.
Well, fine business. Next on the list is Scotty, W2 DFI, the new Tapper president. Go ahead, Scotty.
Drum roll.
Are you there?
Now's not the hot time to have technical difficulties, Scotty.
He's unmuted.
Yeah, it looks like he froze up.
Yeah, we'll come back to him and let's talk. We need to talk to Tom But I think Tom wants to talk to Scotty. So Tom, are you ready to give your report?
Let's see, I can sum this up in one sentence. I've done nothing productive for the last couple of weeks, and we'll just leave it at that.
Well, you've explored a lot of alleys, and all of them have come up dead ends.
Yeah, I'll say this about Quartus. Nothing's worked. No build has worked, no make has worked, no file has worked, no script has worked, no build has worked, no download has worked. And I've now got my board to where I've blown away the factory default and I can't seem to get that back up either. So the golden reference files don't work. And so I've had no luck whatsoever. There's a hole in the wall over here that I've been banging my head against.
That's
Tom,
also
I'd like to
depressing.
offer, I can offer some help because I taught a FPGA design class for 3 semesters here at Case, and Quartus was our engine. So I know how to install it on Linux as well as Windows.
But what about?
I have it up and running. I've been programming it. I've gotten the NIOS processor implemented up. I've got the software for it up and running. None of that functions correctly. I get all kinds of errors, all kinds of build errors. I've gone to the forums. Everybody that I've been able to search are having the identical problems with non-functionality.
Yeah, I never used
in the Max 10 board, right?
Yes, these are the libraries for the RTOS for all of the devices. I've loaded their golden reference images. Those do not work either.
Okay.
And now I've managed
not
to
use the onboard processor. So I can't. Yeah.
Yeah.
Scotty, we can hear you now. Go ahead.
Okay, am I online here?
Yes, you're working.
Okay. Yeah, I had using a different mic during the DCC and I had to readjust it here. I'm up in Minnesota now at a friend's place, visiting the Great White North, nearly the Great White North. So thank you everyone for the congrats on the new position. I'll try to do as good a job as has been done in the past. And this week we've actually made some progress on just cleaning up the parts lists and the parts kits for the RF board and the clock module, because we're getting ready to build them. So now that we got the grant, I don't know if I wasn't here last week. Did Dave, did you mention about the grant?
No, go ahead and talk about it.
The ARDC granted us the money to build the adapter board and the clock carrier board. So we can go ahead and proceed with those. And since those are going to happen, we're going to need RF modules and clock modules, so we can go ahead and build those. So we're getting the BLMs ready, going through them once again, checking to make sure we have all the parts, getting them ready to do build. And that's not being done by me. That's being done back in Tempe right now. So I should be home by the end of the week and continue on from there. So it's a good DCC. It was tiring. I did it in Missouri from my brother's place, and then came back up here to my friend's place in Minnesota to do a couple days of R&R to recover from all the work. So it was a lot of work, but it was a lot of fun. I felt it went really well. It seems like everyone enjoyed it. So we're glad it worked out. So back over to you, Dave.
Well, fine business. And that brings us to the end of the list. I think we've requested some comments from everybody. So we're open for general discussion.
First, I just want to congratulate Scotty on the grant there. That's wonderful.
Yeah, so in addition to the adapter board and the clock carrier board, they included funding for the loopback boards for the data engine when we do actually build it. So that's good news. We'll be ready to rock and roll when the parts come in. If they come in on the time schedule that they say they will, well, I guess whenever they come in, we'll be ready to build them because we have all the rest of the parts.
So now we just have to fix Tom's problems, right?
You just have to fix Tom's problems, and So when I get home, that's kind of the first thing on my list because we need to get that resolved and get license files up and get that moving again because pretty quick we're going to have hardware. So
you have a full license, Quartus, right?
I do.
So you should be able to.
And the thing is, I can
try
get a temporary full float license, and I can get with John, and we can get that temporarily put up, and I think we can do that pretty quickly, because we were offered. But while we're negotiating to try and buy a license and get a grant to do that, additional grant to do that, we'll be able to put up a 60-day temporary license that will be full. So evaluate how that will work. So
Well,
I think that's something that's should be pretty quick on the first on the plate.
It should be worth it to try it with a regular paid license and see if Tom's problems are still there.
Yeah. So Tom, can you either zip up the directory or do an archive for me and put it up on Dropbox, or it's probably too big to send to me. But if you can put it up on a Dropbox or a Google Drive, then I can upload it and compile it. And I won't be home until Friday, but if we can get ready to do that, I'll run it on the whatever version you're running. I think you said you're using 16.1.
Yeah, I built it on 16.1. I also built it on 20.1. Neither of them work. The non-licensed is not the issue. I've got time limited files. Those come up and the processor runs. The C source that I've compiled has all kinds of compile errors. There's no way to get a clean compile. I found where the C code's being incorrectly generated by the tools. I hand edited that, got clean compiles. The gigabit Ethernet interface comes up and negotiates at 1 gig, but then I get all kinds of internal errors. And I can't get an Ethernet address. DHCP does not resolve. I've got those kind of problems. And I went to the support forums and found everybody else is basically having the same exact problems.
Which is ironic because we bought those boards for the exact reason that the Ethernet port was going to work.
Well, yeah. So the board as shipped from the factory does come up and work on Ethernet at Gig E with the board update portal. I managed in my testing today to blow that away. And so I can't get that back. I've then gone and found the board update golden image and tried to reprogram that onto the board. I can make the POF file bring it up a couple of times. It no longer brings it up. The soft file doesn't seem to program it. It takes a long time to go into Flash. It doesn't seem to uncompress and rebuild it correctly. So I now can no longer get the board update portal working either. So I've got absolutely zero functionality now on the board. I can download images, but I cannot get the examples to come up and run. So the only thing I've done is to take the design examples straight from the web page, and they don't work.
Now, Tom,
Yeah, that's not.
If I have a board that I haven't fooled with, is there a way that I either can give you the board or I can give you the code that's on it?
No, I download, while it was still working, I downloaded the package because the links in the documentation are broken. But I downloaded the binaries, and one of the binaries, the POF, worked a couple of times. It doesn't work anymore.
Okay.
The soft file worked a couple of times. And when I load the soft, I get the LEDs flashing correctly, but now the Ethernet no longer comes up and runs.
Right.
I cannot get the soft to reflash it. The programmer works, it says it reflashed correctly. And then when I cycle the board to get it to expand that into the board image, it does not come up and run correctly.
Okay.
So I'm dead in the water. And when I use the soft files, I can get the NIOS 2 to come up and run as a processor. I can get my C code to come up and run. It just doesn't talk to the Ethernet interface. So I'm having basically Ethernet problems. And now I'm having board update portal problems. I have yet to find a single configuration or script that has ever worked when I run it. Not a single one has ever worked.
So you found the original POP file that was programmed into the board when you allegedly when you got it, right?
When I got the board
Have
from
you been able to find that?
from the factory, that came up and ran. And the Ethernet on it.
Right, but did you find that original POP file that you could then reprogram into the board or not?
Yes.
And you're saying you programmed that in and it still didn't work.
Correct.
Okay.
So I got the soft file to work about 2 or 3 times after I managed to blow away the configuration flash. And now I'm unable to get anything up at all.
Okay, because the soft file and the POP file should be exactly the same. The soft just loads it into RAM and the POP loads it into ROM so that when you reboot the board, you end up getting the RAM loaded the way the soft file would load. And so have you checked to make sure all the jumpers and switches are in the same position as the factory defaults?
Yes.
Because that's the only thing I can think of that would be off.
There's one jumper. I've got the switch set to boot up from image 1. There's one jumper I remember removing, and I have it hanging loose on a pin, and I forget what that jumper does.
Yeah, because if that's the boot select jumper, that would explain why it wouldn't work, because it would probably randomly boot one image or the other, and if you booted the wrong one, then it wouldn't work at all.
So there's a dip switch on the back.
That might be what it is.
Okay, there's a dip switch on the back that selects the boot image for the dual boot CPU.
Okay.
And so, you know, I may have to put the strap on. I just don't remember where it needs to go to reprogram the image, and I can't find it in any documentation.
Okay. Because that's probably important, but it just depends on what strap it is. So
yeah,
and the switch definitely has to be in the right position, but it would either work or it would not work. It wouldn't work a couple times and then stop. That's kind of strange.
Yeah, so I powered it down, and I'm letting all my Ethernet switches and DHCP servers time out and all of that kind of stuff. So I'm going to have to track down that strap. I've been able to load soft files and get the hardware to come up and look like it's doing basically the right thing. I can't get the software to come up and run and do anything. Even the master images that are pre-compiled binaries don't seem to work.
Is there potentially some kind of a versioning issue there?
Oh, there's, yes, everything in Quartus has got a versioning issue.
Yeah, is there like an incompatibility between the version of the hard?
No,
for the
the
binaries,
version of Quartus won't make any difference.
For the binaries, it shouldn't matter. It's doing the software builds where the versioning is important. And I've gone in and hand edited a bunch of the C files to get them to compile. No build scripts work out of the box. Everything's broken.
I'm just wondering if the version of the hardware is incompatible with the version of the firmware you're trying to put on. That's all I'm asking.
I have the Rev C hardware, and it's supposed to work with the Quartus 16.1 and the Quartus 21 software I have and the files I have, and they all default to the hardware version. So this is, I'm going to go track down the strap. This has been, there's probably about 60 hours of work in the last week.
Oh boy.
So far, nothing working. So right now, I'm kind of dead in the water.
You have
You
my
hate to see
sympathy.
great leaps backwards.
Yeah. So I'm going to see if there's some documentation I can find about the strap that was on the board.
Whew, that sounds rough.
Anyway, I'm going to let John. I sent you I'm in the process of sending you the design. So anyway, that's my frustration with Cordis.
Yeah.
Yes.
We feel for you. That's not good.
That's an understatement.
Been there and done that, yeah.
And don't want to do it again.
No fun.
Yes.
Very thick fog settles on the.
Backward leaps are not fun.
Scotty, have you and Charlie used the Max 10 board for any of your in-house projects?
See, I'm trying to think. Not really. We've used the IQ2. So, we've gotten the Ethernet to work on that.
Okay.
So,
but the IQ2, isn't that a Cyclone 5? Oh, he's frozen again.
Yeah, to answer your question, yes, it is a Cyclone 5.
I guess he's in Minnesota. He's frozen up.
It's an early October wind.
Well, we have a cold front coming through here in Missouri.
We were down to 42 last night in New Hampshire. Took out the mosquitoes, I hope.
That's always nice.
Went all the way down to 72 here.
Minnesota mosquitoes do not, 42 is nothing to them.
Well, I always liked August in Minnesota. The mosquitoes kind of reduced except at sunset.
Yeah, but they're all the more desperate then.
Mosquito's the state bird up there.
So I have cousins that retired and moved from Minnesota to Michigan, and they sold their house to a couple that was moving from Central California. They wanted to get away from the fires. And I said, do they know what Minnesota winters and what the mosquitoes are like? Because the house is on a lake, which is beautiful. And he said, well, at least the guy grew up nearby, because my cousins used to live in Bemidji. And but the wife grew up in Central California. So it's going to be a shock for her, I think.
Can you hear me now?
Yes.
Yeah, the internet connection is not very stable out here. We got it on a microwave link, and Mike's actually in a club meeting on another Zoom session upstairs. So it's amazing it's working at all.
Okay.
And we get a lot of rain here between the house and the microwave tower. The connection speed goes way down.
Yes.
So the last question was, is it a Cyclone 5? And yes, it is. That's
yes. Well, Dan and I talked about that.
Okay.
So I still have a nicely working IQ2. And I dug it
well, I'm
out.
just concerned. I'm concerned we can't load the original POF file on that board and have it still work. That's disturbing. And it should work consistently. I mean, it's
Scotty.
Should load the same every time.
I dug this out. I want to get it working again.
Yeah, it's an HF1.
It's HF1, and I do have the files. I just have to sit down and figure out how to reload them.
Well, it should, the file should be in that. All you need to do is run HDSDR. You have to have the, what is it? The driver file in the HDSDR directory. That's all you need.
Okay.
And the firmware should do the same.
Okay.
It'll do HD, it'll do DHCP. So just plug it into your network.
I have a question I'd like to ask when this subject's exhausted.
Go ahead. I think it is.
We're pretty exhausted.
Well, and as am I, but I have forgotten a lot more than I know about network protocols and things. And but I always get nervous when I see a lot of just traffic on my local net that I'm not, that doesn't seem to correlate with anything going on. And I mean just the lights blinking on my switches and such, when I know I'm the only one here. And there's lots of devices, but I wondered if anybody could enlighten me. I got worried about this yesterday, and so I fired up Wireshark and captured some blocks and of traffic. And the main thing that jumps out at me is lots and lots of packets. Didn't do anything fancy. I'm not any expert at Wireshark, but all kinds of stuff labeled gratuitous ARP, coming from the Raspberry Pis in particular, and gratuitous ARPs and responses to those, plus some dubious looking DHCP traffic. And I don't really think anything evil is really going on out there, but I think I'm not configuring something on the Raspberry Pis quite correctly. I'm using static IPs on them. I've edited the cleverly named dhcpcd.conf file to give me fixed IPv4 addresses, and also the and in at least one case, I've turned off IPv6. I'm seeing what may be IPv6 stuff in there too. There's a lot of MAC address looking stuff flying around, but mostly I'm seeing these gratuitous ARPs, and I'm not quite sure what to make of gratuitous ARPs. Can anybody shine any light on that for me?
Dead silence.
Dead silence.
I'm trying to unclick them on here. I found factory recovery / dual boot .pof, so I'm trying to flash that into the part now.
Oh, good.
So there's a bunch of things that happen in ARP, and I've got to go look up on the internet what gratuitous ARP is. There are timeouts in ARP tables, and generally I think those are set at 3 minutes. And so if a device hasn't been talked to in 3 minutes, then it will time out and you will lose the ARP entry in the Ethernet switch. And then you'll have to go back and do another ARP again to find it. Is it something like that?
Could be. It almost all seems to relate to these two Pis, and I do have a Ubiquity switch sitting there, but I don't think it's plugged in. Otherwise, I'm just using pretty plain vanilla home networking things, and so I don't know. I don't know why these things are ARPing all the time, but that could have something to do with it.
Yeah, if the ARP timers are set shorter than 3 minutes, I think 3 minutes is the default. Then if the switch doesn't know who's out there, it will send, it's lost the IP address because the MAC address associated with it's timed out of the switch. It basically has to say who has, this IP address, and the responder will answer bringing back the MAC address, and then the switch can talk again.
Okay.
It could be that some software has set that up for shorter than a 3 minute timer.
Yeah, there are a lot of default settings on the Raspberry Pis these days that are not what I grew up with, I guess, and the software changes, and so I'm not always sure what I'm looking at or what I'm poking at. So I may have done something to cause this, but I just, it's sure happening a lot more often than once every 3 minutes or something. It's like a continuous stream of these packets.
Dave, there's a gratuitous ARP entry on the Wireshark help page.
Is there?
The short answer is a gratuitous ARP is an IP address that sends an ARP request out for its own address.
Ah.
It's generally used to look for collisions. Somebody using the same IP address. It may just be a sanity check somewhere in some software looking for other devices.
Okay.
But check that out. There's a Wireshark page that talks about gratuitous ARP.
I will do that. It's been years since I fooled with that kind of tool, and I'm really, really rusty at it. So I'll go back and look. Thanks.
There was one thing that I was reading somewhere when I was setting up Raspbian. There was some sort of an automatic some sort of an automatic thing where the Raspberry Pi would announce itself on the network, and you could turn it off. And I forget exactly where that I was reading it, but it is an option. It's something like it's almost something like Apple's Bonjour service.
Yeah.
Well, that's
kind of what was going
zero
through my
config.
Yeah, that's what was going through my mind.
Yeah, there's something in Raspbian, and I was reading about it, but I lost the link. But I think that's what you're seeing.
Yeah.
And I also noticed on my home network, Windows machines, they also have that zero config network service that blasts your LAN with junk. I always turn that off. And if you have Samba file shares or Windows shares, on occasion you could get a burst of junk.
Okay. Well, I thought others might encounter the same thing and, at least be concerned by it. I'd like to have my setup be clean.
Yeah, I don't blame you. I'm always worried about traffic that I see on my switch that doesn't seem to make any sense. But it's probably that service on the Raspberry Pi, and I think you could turn it off. I'll have to look for the link.
Yeah,
So
I remember another one too.
I was told by Phil Karn that the simple home switches, the zero config software floods the switches with packets, and it doesn't have the appropriate firmware to handle it. So if you had a regular switch like you would use in an office or at work, it which is called a managed switch, it would work fine. But with these cheap ones, they don't work well.
Well, I've just had too many other things to do to get my hands dirty. I've got a bunch of Ubiquity switches that are managed that probably could tell me a lot about what's going on.
Yes.
But I just haven't taken the time to fight with that dragon.
Like everything, it takes work and time to get those things up and running.
Yeah. Well, if I find out anything, I'll let people know.
And Dave, I promise that I'm not trying to hack into your Raspberry Pis. I would be interested to see what Multimag is going to do, but I don't have the ability to hack into anything. But it could be. My Pi is just putting out, spam. But
I
hopefully
doubt it's your Pi doing it to Dave's compute.
I think my outward facing, my public facing wall is reasonably intact against, any, certainly not a serious, a serious state actor or something, but I see no sign that there's stuff coming in from outside, but it just looks like misconfiguration on the pies and or strange configuration. And these things have Wi-Fi on them too, which I have shut off, I think.
Yeah.
But they maybe they're seeing some kind of circular routes. I don't know. But
so it's coming from inside. I mean, I'm just a geologist from New Jersey, in Ohio.
Well.
So I mean, that's way beyond me. If it's coming from inside, I'll mute myself now.
You focus on things that are simple, like geologic processes, right?
Well, now, simple.
I'm teasing you.
Okay.
My
Dave,
father
I wish I could help you with your problem, but
yeah, well, actually, folks have given me some things to chase, so that's usually enough to keep me happy.
Scotty, I seem to have got the factory recovery dual boot off in and loaded, and it seems to have brought back the factory original version. So now when you power it up, it boots up into the normal one, but it still doesn't talk over Ethernet.
Yeah.
And did it originally talk over the Ethernet?
Yes.
Oh.
The LEDs flash correctly now, so the factory image is flashing the LEDs in the right magic sequence. And I'm going to let it cool down and use a 6-foot cable to the switch instead of a 25-foot cable to the switch. See, and I'm going to reboot my DSL modem, see if there's something in there it doesn't like.
Okay, because it seemed like it should work the same as it did out of the box.
Yeah, so I could have goofed up my DSL modem. So after the Zoom's over, I'll reboot that and see if DHCP is happier.
Okay.
Well, I think we need some eyeballs on this. Nathaniel?
I think I need a.
I was going to
Yeah.
ask Nathaniel if Kong could try his out and see if he's getting it.
Yes, you could probably give that a try. Did we get a time slot scheduled to meet with him?
No, you were talking about Thursdays.
Okay, so I will email him again and we'll try to get that scheduled. My schedule is just insane. So
Well, DCC got in the way of most of us, so.
yeah. But I mean, in
Yeah.
general, my schedule is insane. So
Yeah.
yeah, I will email him again.
So, one thing I did want to add at the DCC, there was a lot of talk about or questions about whether a magnetometer could be installed or what conditions were necessary or would prohibit the installation of a magnetometer. And it's too bad Jules isn't here tonight, but I think I've been thinking about this issue a lot, and I think it ultimately comes down to if you're in a high density area with magnetometers, and I guess those don't exist at this point. But for instance, in northeastern Ohio, because Case Western is there, there's a lot of grape 2 receivers. So if all of those people had magnetometers, then I think it would probably be best if you only had one, and if you were you had a fairly urban or rural area, I'm sorry.
Yeah.
But I think even with the influence of cars, that just causes jumps that are I think could be easy to filter out, especially if we're interested in just the magnitude of the jump. And the 60 hertz signal may cause some issues. I'm still trying to work on that, but I think it's going to depend on the location. But ultimately, if people are buying the magnetometers themselves, then it's a question of at what point do we not want to record the data? Or is the recording the data more of a burden than it's worth? And I think that may be a tough call, and that's something that Hyoman will have to think about more. But even in my suburban lot, it seems like there's the potential to collect some good data. But again, if you're in a dense area, it may not be worth it. If you're the only ham in a state, then it could be worth it, because you can always extract data from, even if there's some noise. So I think there were a lot of questions about that. And that's something I think the group needs to think about.
Well, I was thinking that at some point there would be in the database, an academic sit down and develop some sort of algorithm that could indicate high quality and higher quality and lower quality data sources.
Well, and you should have the location of the magnetometer in the data.
Yes.
So you could theoretically look at a map and figure out, well, is this rural or is this urban?
Right.
By looking at how many roads are nearby and how many houses, what the density of the houses or buildings.
But this is
it seems like. Go ahead.
This is a common problem with crowdsourced data, is that it's not all academic quality.
Right. But I think maybe what David's saying is if we find a way to flag the data to indicate its quality, then we can put the data in the database, but then you could just kind of flag it as, oh wait, this is an urban setting, so maybe the data isn't as quality as areas in rural areas.
And I think that's something that the particular researcher is going to want to look at. So it might be nice if they had flags to look at, but they also probably want to look at the raw data.
Yes.
But ultimately,
right. So you store the raw data, but you put in the metadata, you put some kind of flags or ability for the user of the data to figure out how good it is.
Yeah, and that would be helpful. And I suppose, I don't know how many of these are ultimately going to be installed, and how many, are they going to be looking at trends where they want to look at everything and exclude the bad data, or are they looking at specific events like on September 3rd, I want to see the timing distribution of some particular magnetic wave that went through, and those are different scenarios.
And it may be that you want to see what happens on September 3rd, and you don't care that there are cars driving by because you'll deal with that, and you want to see a big perturbation, and you want to see it in spite of the interference that you might get from other outside sources.
So, I think it's important that the raw data is there. Now, and I suppose any researcher who knows what they're doing will be able to, they would look for things to filter out or problematic data on their own. It might be useful to have flags. And if we were producing, sort of like some of these USGS magnetometer stations produce, what do they call it? The, certified or non-preliminary data that they have gone through. I think our data will always be raw and sort of preliminary. And so it may be up to the researcher, it's always up to the researcher to examine their the data and figure out what's going on. Some flags could be
Sure,
useful.
but you want to give them enough data so they can figure out when the data is not as good as when the data is better. So what I'm thinking is you could do some post-processing and say for instance, if you determined a way to detect vehicles driving by your magnetometer, and you could detect that and say, okay, here's the time periods when the data is not as good because I got all these interfering vehicles coming by, and here's the data that is better, like say in the middle of the night when there aren't any coming by. And if you could somehow include that data so that the researcher can correlate that with the raw data and adjust it however he wants to do it.
Well, and that would be perfect. And especially if, we could, let's say there's an algorithm or filter that's in R or Python, and that could be posted, and so it could be an option for them to use, but ultimately they're still responsible for the data they're using.
Yeah. But they may have no choice but to mount it near an interference source like vehicles or power lines or whatever.
Oh yeah, and for instance, when I moved my magnetometer, and then the school opened up, the buses come by, and when school opens and closes, I get a huge spike, both from the magnitude of the buses, and I think maybe some of the electronics in them. And so that could be easy to filter out.
Oh.
And it would be great to offer an option to filter that out, but still the individual researcher needs to understand the filter. They need to see what's going on in the background.
It's kind of like mounting your weather
station
station next to the incinerator, and twice a day the temperature goes up 25 degrees. I mean, so you have to identify the times when you're being interfered with, and the times when your raw data is better than or is good.
Yeah, no,
I don't know how to do
that would be
that.
useful. I think now I understand what you're saying is if the user can say, I know what's happening during this particular interval,
Like your bus is going by,
or this is when school lets out and the school buses are going by.
Probably all those cell phones all in one place.
It could be.
Yeah. And don't the buses have GPS locators on them? They're transmitting back their location constantly.
I'm sure that's the least of it, though.
I don't know. I think there's one particular spike. I think it could be some bus that has some weird ignition issue. I'll have to look at that more closely, but I think there were certainly a lot of questions about, can I have a magnetometer here, and is my location going to be too noisy? And I think the answer is complicated, but I think you can even get useful data in a noisy location. Something to think about.
Yeah.
I don't know the answer. I'm just a biologist, a paleontologist from New Jersey.
Nathaniel, this sounds like a discussion we've been having with Phil regarding the accuracy of the spot data,
right,
in PSK, and how to evaluate the quality of it.
Mm-hmm.
It's hard to, when you have data coming from a variety of different sources put together by amateurs.
Mm-hmm.
It's hard to know really what the quality of it is.
Mm-hmm.
What is the quality of your quality evaluation?
Mm-hmm. I have to tell you, even from working on the Super Darn project, which is not amateur, it was difficult.
Yeah,
so,
it doesn't matter whether it's amateur or professional. you still have, the quality can vary.
But is it kind of the idea that we just have so many of these that it kind of averages out?
Well, yes, it's true, but you still want to try and get it as good as you possibly can,
Yeah.
right?
But I
Like
mean,
if,
ideally, if you had a super high density of them, then you could actually see areas that were interfered with because they would come across in more than one magnetometer.
yeah, it's definitely one of the strategies we're using.
And hopefully that's true if there's enough density at any one point.
Yeah.
And for instance, where I am in northeastern Ohio, there's going to be a high density. But then you get to other states and they may be lucky if they have one.
Mhm.
But I mean,
But you
Scott,
can't
you're
always
exactly
count on a
right.
high density.
That is the ideal.
And what if they're all wrong?
What's that?
What if they're all wrong? Like,
I'm not a philosopher.
I mean, it's kind of like the things they say about clocks too. If a man has one clock, he knows exactly what time it is. And if he has two clocks, he doesn't know what time it is.
Yeah, but I think if you have multiple magnetometers in Ohio and they're tracking with a US
same thing.
station,
Yeah.
and this is what Bob Benedict and I have been able to do with our grade.
Yeah.
You know,
I completely agree with that.
They track it. It's probably not random noise. They're probably tracking something real. Now,
I completely agree with that. And that's exactly the same technique that I'm using with my LSTID study with all of the WhisperNet data, where I'm looking at that traveling atmospheric disturbance. I'm saying I have a very noisy data set, but when I put everything together in aggregate, I'm seeing a coherent pattern in there. That's not a mistake.
Yeah.
But the
Well, I
noise
think
does
the
not
point
correlate.
that Bill was making today and in our emails, you need to be able to put error bars around your values so that you have an idea of how good they are.
But if you have enough units, then you can do that because you can judge which areas are not correlating with other areas because the noise won't correlate. So the noise should be able to be identified and removed because it doesn't the readings close by should theoretically correlate, but the noise sources will not.
For the majority of space weather or space physics related phenomena are on a large scale. So, for example, the event that I showed during the presentation, I had a comparison between magnetometer data from Fredericksburg, Virginia, and Hope, New Jersey. The overall trend is very similar. So even with that kind of distance, the overall trend should be similar enough so that we can sort of identify any kind of abnormal, local, intermittent noise pretty easily. As long as the noise is consistent, say 60 hertz noise or car passing by that causes like very abrupt, very short noise, that can be identified pretty easily. And I bet there will be a bunch of ham-side magnetometer nearby so that we can see patterns and then we can sort of spot from one or two bad ones.
So when you see a disturbance in the magnetic field, it's not going to look like a car going by. It's going to affect lots of magnetometers, right? It's over a large area, isn't it?
Correct.
I mean, that's what we're trying to measure.
Correct. I'm talking about
the local,
more than hundreds of kilometer spatial scale.
right. And so the school buses aren't likely to drive by two locations at the same time compared to the magnetic disturbance will affect multiple units at the same time because it's a larger event. So I mean by correlation. So you're going to see if you get a big disturbance in the magnetic field, you're going to see it over lots and lots of magnetometers in a big area. Whereas the school buses and the vehicles and the small disturbances, they may be significant to that magnetometer, but they're not going to be present in all the other ones.
Yeah, that's the case with that so-called, what I call the bat signal that we saw on August 29th. It appeared in Fredericksburg and New Orleans and here. And
Yeah.
the shape was the same in each case.
But the local QRM of vehicles and things won't look the same. So.
Right. It's going to be unique to a particular sensor.
And parked vehicles are, at least on my station, very obvious, because you can just see all of a sudden the signal goes up and it stays up until it, leaves. And so I can look at my magnetometer and be like, oh, that the next door neighbor went to work. He always
That's exactly
7
what
when
I
he gets
was going to
home.
say.
You spy on your neighbors. That's a good thing.
That's exactly what I was going to say. I'm more concerned about distortion of the magnetic field rather than short, intermittent voice source. Because if you are not really aware of like big magnetic source that can distort your magnetic field measurement, it can be a problem because it doesn't look like noise. It will just distort the magnetic field measurement. So.
Well, you're talking about like when the bus parks next to his magnetometer,
right?
And the readings are just off.
Big, metal chunk that's been sitting there for a long time, and you're not aware of that. Then it can eventually distort magnetic field. It doesn't look like noise. It will just distort magnetic field.
Well, so is that a problem? That I couldn't quite hear. The audio was a little broken for me, but so I mean, is the bus causing distortion or just a offset?
Offset. I was talking about offset. If a bus passes by, you can easily identify the noise source. But if there's a bus that is sitting there for a long time, which you don't really recognize, that can distort the magnetic field, which can be a much bigger problem than notifying some kind of car or big chocolate metal passing.
But would that distortion be? Could you identify that from just, let's say there happens to be a piece of metal you don't know about in the ground? Wouldn't that distortion be the same as not having the magnetometer aligned correctly? In that, yes, it's a distortion, but if we're still looking at change of values over time and it's static, I mean, we're not looking at absolute directions here, because none of us have the ability to align or calibrate magnetometers.
Correct. But that's a little bit different situation than having the sensor misaligned, because in a situation where you expect to see, say, 100 nanotesla change, if there's a big chunk of metal, then you could see, I don't know, maybe 250 nanotesla change or 150 nanotesla change rather than 100 nanotesla change. So your data may look different in the sense that the change that you see could be a bit over or underestimated.
So how would one know if their magnetic field was distorted by some? I mean, I can't say there isn't buried treasure next to my magnetometer, which could be a huge metallic mass.
It is based on assumption that if you are in a rural area, I mean, if your area is rural enough, then there's no, big chunk of metal sitting next to you. For example, like any modern big building has a really big steel structure inside. So it's not wise to have magnetic sensor right next to it. Whereas if you're living in a rural area, most houses are not so metallic, I guess. And you don't really have big chunk of metal somewhere on the ground. So it's based on assumption. unless you have a hidden treasure somewhere, like the big submarines. So
So it sounds like you're saying that it should really only be in rural areas, that I in a suburban area.
I mean, what's the difference between suburban and urban? I mean, like, I don't know. I mean, if I would not have a magnetometer in the middle of Manhattan, for example, but if you're surrounded by all like residential area with no big power source around, I think that might be okay. I mean, I don't know. I mean, this is just a try and error kind of problem.
David, by the way, I was looking at where you're located on the map, and I lived within 5 miles of where you are for like 12 years when I was
really?
working for General Motors. There was a General Motors plant called Packard Electric in Warren.
Okay, yeah.
And I worked for them for 12 years. So I'm familiar with the area where you're living. And I'm sure there's buried treasure all over the place that you're just not knowing.
I mean, in an extreme situation where we were installing much more sensitive magnetometer near some kind of like power tower, electricity tower made of metal. You know, even though there's no big disturbance from there, but whenever there's wind, you can actually pick up the signal from the motion of this big chunk of metal right next to you. So, I mean, for obvious reason, you don't want to put your sensor close to, you know, big metal tower, for example. So I'm talking about that kind of extreme. Like I'm not talking about like surrounding.
No, I understand that, and I guess it's a question for the scientific aspect of this is how many hams do you think are going to want to install the magnetometer, and how many of them are going to live in the rural areas that or how many are going to live in rural areas. So I guess it's a decision. I mean, of course, the hams are paying for them, but you're going to have to decide, do I want more magnetometers, or do I want to limit the number of magnetometers without knowing how many people are even willing to install them? And I can't answer that question.
Yeah, I guess that's more of a hand-side question rather than a magnetometer question.
Well, but I mean, it's for science, so it's a real question that, I mean, it's a relevant question that.
Yeah, it's a very good point.
Well, earlier, Hillman, you used the term trial and error. I mean, I think each person should, anybody who puts in a magnetometer should collect data and compare it to what it looks like from the closest USGS magnetometer to where they're located. And if you're definitely in a terribly bad area, you're not going to see any correlation. It's going to be all over the place. If you're in an area that's conducive to getting good measurements, what you get on a given day, the shape of it is going to be very similar to what you see in the USGS magnetometer that's closest to you. At least that's been my experience. I can compare my results to the data in Fredericksburg and New Orleans, and they look very much the same. You can lay them right next to each other. They look just alike.
And especially if you're looking for the spatial distribution of a temporal change, then you're just looking for a blip. And even if there's a distortion in the various axes or alignment issues, you're looking for when did this disturbance come through in a temporal sense.
Yeah.
And that's not going to be as controlled by any distortion. But again, I'm not using this data professionally, so I can't offer any insight as to whether or not it'll be useful.
Well, I don't know whether we've really defined how it's going to be used professionally. And that's kind of a question for Nathaniel. Do we have a plan on how we're going to use magnetometer data?
That more falls under humans regime.
Yeah.
But the idea is, my idea is we would bring it all into the central database, and then someone like Yeoman would go through and, mine the data, analyze it for.
Seems like there's a good opportunity to apply some machine learning to maybe spot things that seem to be correlated with geomagnetic events or solar events or something like that.
Well, since our science target is space weather related, where magnetic field disturbance is quite large scale, like on the order of say at least 100, 200 kilometers. So my initial hope is that our magnetometer network is much more dense than what we have here with the USGS magnetometers. For example, like you have one in New Orleans, you can still compare your data to Fredericksburg, Virginia. That's fine in a broader context. So my hope is that you would have much more magnetometers somewhere between Fredericksburg and New Orleans, for example. So then we can easily compare magnetometer data side by side. Then we can sort of rule out some bad data quite easily, I think. We're not looking for really, really small scale, short-lived phenomena as HF community does. So I guess in terms of providing some kind of contextual data in relation to a big phenomena such as geomagnetic storm or substorm, I think somewhat more dense array than what we already have with the USGS magnetometers. I think we should be able to see provide some pretty good contextual data. So that's my hope. As long as we have more data sets, more data points than that we already have, I think we should be able to do something scientifically.
Yeah.
But my hope is that we like to have more data points at higher latitude than New Orleans, for example, say Alaska or Canada, because that's actually more connected to the boundary between the solar wind and magnetosphere. So the phenomena over there will be much, much more dynamic than lower latitude area. That means we need more space. We need more dense array there.
Yeah. And we need to try and recruit stations in Alaska and Canada.
Mm-hmm. And naturally, then those areas tend to be much more rural. So.
Yeah.
Like if you say Alaska somewhere, except for maybe Fairbanks or even Fairbanks. I mean, what is it? Anchorage. Yeah. Other than Anchorage, pretty much everywhere in Alaska, you can say that it's rural. Unless you make a huge mistake in installing your magnetometer. So I'm not talking about like dense array in New York, Manhattan. I'm talking about dense array in New Orleans. I'm talking about overall big picture kind of magnetometer network.
All right, I'm going to say goodnight, all. I'm running down. But Nathaniel, we will talk to you at I guess it's 0900 your time.
Yep, I will talk to you tomorrow.
Okay, 73 all.
I'm gonna say 73 as well. Thank you.
73.
Me too. Good night, all.
Good night,
Bye-bye.
everybody.
Bye.
Good night.
All right.